We're now at the end of our separating techniques unit, and the last thing the specification talks about us wanting to know is about using separating techniques. And they particularly talk about how we make water safe for drinking. So that's what we're going to be doing in this video. Why is it not advisable to drink river water? Well, there's two reasons. One, it has solid particles in it, e.g. Silt or sediment, or leaves, or indeed any sort of solid matter, and it's not great to drink that sort of stuff. Two, bacteria. Okay, so water found in the environment often has bacteria in it, and that can make us very ill. Diseases such as cholera and typhoid have killed literally millions of people in the last century through drinking contaminated water supplies. So we need to remove the solid particles, we need to remove the bacteria to make it safe to drink. So, how can water from a river be made safe for drinking? Number one, we've got to deal with those two things. We've got solid particles in it. What separating technique do we use for removing solid particles? Filtration. Okay, so the first thing we have to use is filtration. Now, I don't use filter paper. I don't have one sort of giant filter paper to make all our river water or our reservoir water safe for drinking. They use beds of sand filtration on top of gravel, and that gets the solid particles out. And the second one, I've got the bacteria in drinking water. Chlorination, addition of a tiny amount of chlorine kills bacteria. I was reading an American article, I think it's in American Journal of Science, that describes the chlorination of drinking water as one of the public health successes of the last millennium, one of the greatest advances in public health in the last millennium. So it's been that important in making drinking water safe. Okay, so chlorination kills bacteria. And the filtration removes solids. Okay, chlorination kills bacteria. I mean, we were advancing the science on that at the moment, and things like UV light would also do the same thing. Certainly the main swimming pool in Norwich, obviously we chlorinate swimming pool water. The main swimming pool in Norwich is reducing the amount of chlorine they use, and they've got a UV light set up to remove the bacteria in the swimming water. So that works as well. Okay, why would seawater have to be treated differently to river water to make it safe for drinking? Well, seawater, of course, is salt water. Seawater has dissolved salts, and they will need removing. So river water in the United Kingdom is fresh water. It's come out of the sky, there's no dissolved salt in it, or very little dissolved salt in it. Seawater has really quite a large amount of dissolved salt in it, so much that it would make it unsafe for people to drink. So we have to remove those dissolved salts. So how can water from the sea be made safe for drinking? Well, again, it would need filtering. Okay, got seaweed in it and things like that. Filtration first, and then distillation would work to get the dissolved salt out. So the salt would remain behind, and of course the water would evaporate off, and then it condenses, and that water that's condensed is collected, and it's safe for drinking. So distillation is a separating technique there. Why must water used in analysis not contain any other dissolved salts? Well, if we were testing for, say, chloride ions, it's a standard test. We add silver nitrate and type nitric acid. And if we have silver ions present, we get a white precipitate. So that's the test for chloride ions. Okay. If we were to use water that has, been treated with chlorine to kill bacteria, then we're going to get a false positive result. A false positive. Okay. So we do not get a false positive result. Now, if we look at things like spring water, where water's come up through the ground, then often it's got lots of dissolved salts in it. And if you look at the back of any sort of a fresh water or spring water bottle in the supermarket, you'll see a list of the dissolved salts on it. So we use distilled water. For testing in chemical labs because it doesn't have those dissolved salts in it. We evaporate the water off and we condense it. How can you get dissolved salts out of water to ensure it's pure for analysis? Answer, distillation again. Okay, distilled water does not have dissolved salts in it. That's pure water. The dissolved salts remain behind in the flask. A good example of that, I suppose, if you look at your kettle, especially in Norfolk, as the water's boiled off, those dissolved salts are often left behind in the kettle, and we call it lime scale. That's just the dissolved salts are remaining behind in solution. If we evaporate off the water and recondense it, we get pure water, and that's good for chemical tests. And that's the end of the separating techniques unit.